Hello everyone, today we are going to explain line clipping algorithm. Now the conventional line clipping algorithm uses a rectangular view frame or a window, but we are using a circular frame. This is the approved figure for using a circular frame. Now for the circular frame also we will consider 4 cases, and these are the 4 cases. First of all, the line is inside the frame, 1 point intersection, 2 point intersection, and the line is completely outside the frame. Now for this case we'll consider like the endpoints of this line, and we know the center. For we have the endpoints of this line, so we'll find out the equation of the line, and after getting the equation of the line, we'll find the perpendicular distance from the center. Now, if the distance is more than the radius, it is obvious that this distance is more than radius. This line is outside the circle. Now, similarly, we'll find the distance for each and every line which is intersecting or outside or inside the circle. Now for finding the equation of the line, we'll use this formula, as you can see, where minus dy by dx is the slope of the line. Now we'll solve it further, and we'll get it to the final equation, which looks like this. In this we have substituted minus dy by dx as m, and this y1 plus x1 into dy by dx as c. And finally we get the line of equation as this. I want to apologize. As you can see, this is not the equation of line. This is the value of c which has been substituted in this. That is y1 plus x1 into dy by dx. Now for finding the distance of a line from a point, this is the generalized equation, as we can see, where the generalized equation of line is ax plus by plus c, and the point is mn. For us, mn are the center is the center of the circle, and ax plus by plus c is this equation, that is mx minus y plus c is equal to 0. Now this is the distance formula, as you can see. Now we'll substitute the values of a, b, and m and n in the formula. We'll get the equation as this, which is m into c1 minus c2 plus c upon under root of m square plus 1. Now we'll compare this distance with the radius. Now if the distance is greater than r, that is radius, which implies that the line is away from the circle. If the distance is less than r, the line is inside the circle, and if it is equal to r, then it's a tangent.
As she has explained all the things, and if d is greater than r, then we don't bother about that line, and we'll directly not plot that line in our figure, so we'll discard this case. And now for the other case, we need to consider this case, that is line is intersecting with one point. So for that case, what we have to do is we have to put these endpoints in our equation of circle. After putting the endpoints in equation of circle, we'll get t1 or t2. After getting t1 and t2, we'll compare. If t1 is less than 0, then we can say that that point is inside the circle, and if t1 is greater than 0, that point is outside the circle, and if t1 is equal to 0, then it is on the circle. Same goes for the t2. So we'll have two cases, that first endpoint is outside the circle, or second endpoint is outside the circle, or it is intersecting or on the line. Now for that case, we need to, if we have this case, that is both the points are outside the circle, then what we have to do is we have to find these two intersections and draw this line. So for doing that, what we have to do is we have the equation of a circle, we have the equation of a line. Now we'll replace this, and after solving this, we'll get this equation where we'll get our resultant x and y, and if there is one intersection, then we'll find only for a plus, and we'll get the intersection points.
Now we'll execute the code. As you can see, the library used, and now we'll start the code. And we have taken two endpoints, which are the endpoints of the line. For the first case, we have considered these coordinates. Now we'll find this is dx, dy, and we have set our radius value and the center value. Now we'll find the equation of the line, and we'll find the form. We'll also find the distance, which is delta in our code. And now we'll compare delta with r, and this is the else if conditions we have used. If the delta is equal to r, then it's a tangent, and if it's greater than r, then there's no intersection.
And for the other case where we'll have an intersection of the points, then we'll compare all that things. First we need to find that DZL as we have shown in our notebook. Now we'll find T1 and T2. T1 and T2 is the points which will tell whether the point is inside the circle or outside the circle. While comparing, if T1 is less than 0 and T2 is less than 0, then both of the points are inside the circle. So we'll simply plot that line with no intersection coordinates. For the second case where we are having T1 is less than 0, for that case what we'll do is our first point is inside the circle and second point is outside the circle. So we'll find a new intersection point, that is one intersection point. So we'll find plot the line with first coordinate and second coordinate which is having a new intersection point. For T2 less than 0, we'll plot a line using second coordinate plus the new intersection coordinate, and the third case is where T1 and T2 both are greater than 0, so we'll plot a line with new intersection coordinates.
Now we will execute the code. This is the line with coordinates, and as you can see, this is one intersection point. As you can see, this is the output, but due to some disparity, our code is not working fine.